Okay, so today is 1.2.5, but the first thing I want to do is review with you about finding odd and even. I'm going to do one with you, and then I'm going to have you do one. So here's a function, y equals, or actually I should start with f of x equals x to the third plus 2x plus 1. That's a function. Now the question is it odd, is it even, or is it not odd, not even, and therefore a neither? So you can't just tell by looking at it. You have to do a little process. And I hope you remember you start with f of negative x. So I stick in a negative x in all the spots where the x was. I put a little parenthesis. Does the parenthesis matter? Yes. If you don't have the parenthesis, do you get that this would mean negative x cubed, which actually is a different thing than if there's parentheses around it? So yeah, drop in empty parentheses wherever the x is. Final answer, f of negative x is negative x to the third makes negative x to the third, because it comes out negative, because when you cube something, it doesn't make the negative go away, minus 2x plus 1. All right. Now, is this the exact same thing as this? Because if it is, the function was even. What do we say then? Triangle of dots means what? Therefore, and then not even. You're correct. Now, what do? Factor out a negative 1. Negative 1 comes out of this, and we get x cubed minus, plus 2x, and then the negative comes out of that, minus 1. Ooh, so close. But since this is not the same as this, it's close, but that last symbol is different. It's not odd. And it's only after you've proven it's not even and it's not odd that you can therefore say, therefore neither. So common mistakes, kids sometimes just think, well, I can see it's odd because of the symmetry it has, so I'm just going to say odd. You have to prove it. You have to prove it with this process we're showing you here. If you haven't factored out a negative 1 in front and shown that this and this are the same, you haven't proven it's odd. You can't just say it's odd. You have to prove it. Okay, so make sure you show your work on these. Let's have you do one all completely by yourself and test and see if this is even or odd or neither. 1 over x squared. It's not just a parabola and therefore even. It's 1 over x squared. So what do you think? Is it even? Yeah. All right. Here's how I'd prove it. I stick in f of negative x, and I would have 1 over empty spot squared, and in the empty spot I drop in negative x, and then this becomes 1 over x squared. And that's the same as that, which proves this is the same as this, and that's the definition of even, if f of negative x and f of x are equal. Remember that definition? The definition of even functions are if f of negative x is equal to f of x, then it's even. Would you please try to write down what the odd definition is? The definition of odd is if this is equal to that, then it's odd. Try to write out the definition for odd. I hate to have you lose a point on the test for that one. Okay, starts exactly the same way. F of negative x has to equal, remember how we factor out that negative 1? Negative 1 times f of x. Do you have to have negative 1? No, you can just say negative f of x. And that's the odd rule. Does that make sense? Okay, good. Then you get evens and odds. That's how you tell if things are even or odd functions. Now, let's go to the new stuff for today, which is about finding horizontal and vertical asymptotes of functions. So this one relates back to higher algebra, where you learned big round bottom, bigger on top, and same on both. Okay, do you remember those three things? A function that's a fraction function, like this, is either bigger degree on top, bigger degree on the bottom, or same on both. I'm going to go really fast. If you took like 3 days to learn this in higher algebra, I'm going to take like 5 minutes to learn it right now in case you've forgotten it. So the degree is what exponent it has on it. So the degree on the top on this one is bigger. Do you get that? I'm going to show you another one. 2x squared over x squared. Is it bigger on the top because it's got a 2 in front? No. It's all about the degree. This degree here is the same on both. So that one would be a same on both. Okay, let's say I had 5x to the third minus 7x to the fifth all over 2x squared. Well, that makes it pretty obvious. How about if I make it 2x to the fourth? Now, is it bigger on top or bigger on bottom? Bigger on top, but isn't the top degree 3? No. The top degree is what? 5, because you take the bigger of the exponents. That one's bigger, degree is 5. Some people think the degree is 8. It's not. You take the biggest exponent that you have. Okay? Now, that means this is degree 5 compared to degree 4, so it is bigger on top. All right, last example. That compared to this. Is it bigger on top, bigger on bottom, or same on both? Good catch, same on both. Why? Because if you multiply the bottom out, wouldn't it have an x squared in it? So therefore, it's same on both. Okay, good. So now you get bigger on top, bigger on bottom, and same on both. Now, what do you do if it is bigger on top, bigger on bottom, or same on both? Bob gives you an answer of y equals 0. That means if it's bigger on the bottom, like for instance, if I make this be degree 2 down here and degree 1 on top, then it's bigger on bottom. And if it's bigger on the bottom, it'll have an asymptote at y equals 0. Now, there's some dumb things I'm going to say to help you remember these, because these can be hard to remember. But there's horizontal and there's vertical asymptotes, right? Bob helps you get horizontal. They're horizontal asymptotes. And Bob is a 0. Another thing I'll tell you that's just dumb, but it might help you remember it. There's no bots. Kind of like robots, no bots. So there's none when it comes to the asymptotes. There are no asymptotes if it's a bot. Horizontal asymptotes. And then same on both. Those are an SOB to figure out. They're the harder ones to figure out. Because they're a ratio of the lead coefficient. All right. Or you could say they will make you sob because they're so hard to figure out. Anyway. Okay. So Bobs are just y equals 0. Simple. No bots, as in bigger on top, then there's no asymptotes of this kind. And the same on both is the hard ones to figure out, and they're a ratio of the lead coefficients. The lead coefficient here would be 1 and 1. So if I make this a same on both by making that an x squared, again, this fact that this is a 4 versus a 2 is irrelevant. They're same on both. And if it's same on both, you say y equals a ratio of the lead coefficient, which is that one and that one, 1 over 1. So y equals 1 would be the asymptote. There would be an asymptote line at y equals 1. Again, what we're doing is a graph here. So if there's a graph like this and there's an asymptote at line y equals 1, that means that the graph somehow has an asymptote like this. Maybe it goes kind of like this and this or something. I don't know. You could find out by using a calculator, but you wouldn't have a calculator for this. All right, make sure you are with me and not watching something funny, because what I'm telling you isn't that hilarious. Be with me, please. All right, I'm not telling who I was talking about. All right, would you please try this one? 3x to the fifth minus 2x squared all over 4x minus 8x to the fifth. I want you to figure out, is that bigger on bottom, bigger on top, or same on both? And then, therefore, is the answer no bots, as in none? Or is it Bob is a 0? Or is it same on both, therefore a ratio, and therefore the y equals like 9/10 or whatever the ratio is? You're warm but not right. You're right. Nice job. Keep it covered so nobody sees it. You're close, but off slightly. You are right, sir. Nice job. You've got it. You missed something, a little thing. You're right that it's same on both, but you messed up your what the lead coefficients were. You've got it. You've got it now. You've got it. You've got it. Your lead coefficients are not correct. You got it, except one of your lead coefficients is off a little bit. Yes, you've got it, as long as that top number is a 3, which it looks more like a 5, but... All right. So this one was the same on both, and almost everybody seemed to know that. So you're all trying to do the ratio thing, which is right. Y equals a ratio of the lead coefficient, but what's the lead coefficient? The lead coefficient is the one that's on the biggest degree. So the 3 and not the 4, the 8, but not just the 8, the negative 8. So it's 3 over negative 8, or negative 3/8. There would be an asymptote at negative 3/8. Okay? That's about as hard as those kind get. That is the horizontal, and Bob helps you to get the horizontals. All right. Now, let's talk about the verticals. If I had this... Wait. Okay, here we go. Do you remember me saying if you can factor it, you should? Factor the top and factor the bottom on this. Nothing's going to cancel, but it's going to help us find some stuff that's important. Factor the top and factor the bottom. The bottom is actually easier to factor than the top, but the top is not 2 sets of parentheses. Don't like beat yourself into the ground trying to factor it with 2 parentheses. It would be pretty much impossible. Just factor something out of the top. Okay, here's what I was going for. You get how there's an x in both of them? X comes out. X plus 3. On the bottom, that is a classic pattern called difference of squares. I've had these on my top 20 sheet to remind you about them. X plus 4 and x minus 4. There we go. I got it factored. Am I done? Well, if your only question was to factor it, you would be. But the question on this one is to find not the horizontal asymptotes, but just side note for a second. If we wanted the horizontals, is this bigger on bottom, bigger on top, or same on both? Same on both, and therefore it's an SOB to figure out, and therefore you go y equals a ratio. Y equals a ratio of what to what? 1 over 1. So the answer is there'd be an asymptote line at y equals 1. Okay, but that was to do horizontals. To do verticals, it's all about the base. Have you heard that song before? Okay, well, this is the bottom of it, and it's all about that. This tells you your vertical asymptotes. And now I bet you now that it's factored, you probably know the 2 things. There's 2 things here that are going to cause a problem. Do you get that negative 4 and positive 4 are going to cause a problem? Then think about it in terms of a graph. When something won't work in the graph, it makes an asymptote. Does that make sense? Before, all we cared about was the domain, like what doesn't work. Everything works except 4 and negative 4. But now what we care about is what actually happens when you stick a 4 into the function. It makes an asymptote. So you get 2 asymptotes. The vertical asymptotes are at x equals 4 and x equals negative 4. You might be saying, but you used to say it can't be 4. Yeah, that's the point. You get an asymptote when you put in 4. An asymptote isn't like a thing in the function. It's a place where the function can't be. So like there's asymptotes here and here, and the graph going like this. Those are places that the graph can't go. And if we're looking for a place the graph can't go, places that make the denominator 0 are good for that. Okay, so the moral of the story is, when you see a problem like this, first of all, you just think, oh, I can factor that. Factor it quick. Just write the factored answer down. And then tell me what you think the vertical asymptotes would be. Is Bob the one who tells you about the verticals? No. That would be for the horizontals. This one, it's all about the base. And you should have said x plus 1 and x plus 1. Don't let that bother you that you get the same answer twice. The answer is just that, which is -1. And x equals -1 is obviously an important spot. It is not going to work in the function, so the domain would not include -1. It would be everything except -1. But what actually happens when you put in -1, you get an asymptote. So the vertical asymptote is x equals -1. There we go. Now let's go back a second and say, what would the horizontal asymptote? Bob usually helps out with that. Is this a bigger on bottom, bigger on top, or same on both? Bigger on the bottom. What's the rule for Bob's? What's Bob again? Bob's a 0. So for the horizontal asymptotes, y equals 0. So there's an asymptote this way at -1. That's vertically. That's up, down. And then there's a horizontal asymptote at y equals 0. And Bob is the one that told you about that. It's bigger on the bottom on this one. So that's a typical question for today. They'll give you this problem, and they'll say, what are the horizontal and the vertical asymptotes? Okay? Does it get more complicated? Well, yeah, just because the functions sometimes are a little more complicated. But remember, here's a really common mistake. People think that -2, -3, -4, and -5 are all important numbers. They're not. The top ones don't matter. If you're trying to find asymptotes, horizontal and the vertical asymptotes, you only want, Bob will tell you about the horizontals. And is this bigger on bottom, bigger on top, or same on both? Same on both, and therefore what? If it's a SOB, it's an SOB, it's the lead coefficients. If you multiplied this thing out, what would the lead numbers be? The lead number is that number and that number. Come on. Thank you. So go ahead and finish this off. The horizontals are, Bob tells you about that. Is this a Bob? No, it's the same on both. So if it's the same on both, it's a ratio. It's a y equals 1. And then the vertical asymptotes are not all 4 of these things. -2, -3, -4, and -5. It's only this. It's all about the base of it. It's x equals -4 and x equals -5. Last thing they usually throw in on a question like this is, what is the domain then? Domain is also all about the base. Always start your domains with all real numbers so you don't forget that everything works except what? And we got to think about this. What works? Well, everything except what? X cannot be what? -4, and x cannot be -5. Could I have done that with a number line? Sure. Here's -4. Here's -5. Oop, wrong side. That'll have to be -5. And that'll be -4. It doesn't work here, doesn't work here. It works everywhere else. And if you use interval notation, you'd say from -infinity to -5. Union with -5 to 0. No, -5 to -4. Union with -4 to infinity. You know what I mean? You'd have 3 intervals where it would work. Okay. It's about as hard as they get. So now I'm going to actually start your homework with you. So everybody, if you can find your new homework, it's 1.2.5. It looks like that. I was doing really hard ones. Now these are gonna feel like, that's easy. Good. Remember, Bob tells you about horizontals, and Bob's is 0. This one's actually not a Bob, though. It's same on both. So I would go y equals 1 over 1, which is y equals 1. Okay? And then how about the x? It's all about the base. What would screw this one up? 1. So you'd say x equals 1. Another really common mistake people make is confusing verticals and horizontals, like when they write them. Like if I write this, which one's the horizontal and which one's the vertical? It's really easy to get messed up. I'm telling you, at least a third of you would get this wrong right now. So I'm going to give you a way to remember which one's the horizontal asymptote, which one's the vertical. The vertical and the horizontal asymptotes. Get where I'm going with that? The x ones are the vertical asymptotes. The y ones are the horizontals. So I'm going to call them the horizontals. It'll remind you that it's a y goes with horizontal. Because see, this is the part that kills me on the test. It'll say, what are the vertical asymptotes? And what are the horizontal asymptotes? And the kid will put the wrong ones in the wrong blank, and I get it wrong. You know what I mean? So let's think about it again. Which one should I put in this vertical asymptote blank? The x ones, like x equals 2. And which one should I put in the horizontal? The horizontal, the y things, like y equals 0 or whatever. Okay? If you were to reverse that and put this down here, nope, can't be right, because the verticals have to be x equals things. And the horizontals have to be y equals things. Okay? All right, I've told you a lot of stuff fairly fast, so I'm hoping you're ready for this homework. If you haven't already, please get this up on your iPad. And there it is. Let me see size-wise if this is appropriate. It is pretty appropriate. I think we could probably skip one of them. Let's skip number 3. It's not too hard, but you can skip number 3 if you want. I want to leave 4 in because it has factoring in it. I want to leave 5 in because look at that base. A lot of people think you can factor that, but you can't. So that means that it's all about the base, right? What could make the base 0? Nothing. There's no way to make the base 0. So then if there's no like x equals 3 to use, is it possible there are no asymptotes for it then? Yeah. Now it's bigger on the bottom, so it's got that kind of an asymptote. Let's just do number 5 right now. Since it's bigger on the bottom, what do we say? Yeah, so what equation goes with that? Y equals 0, very good. So you have y equals 0 written down. I wish I could write it on the board right now, but that thing's smart ink is broken. So you go y equals 0, and then how about the x things? It's all about the base. Can you make the base ever be 0? No, you can't. You'd have to make x squared come out to be -1. You can't do that, right? So you can't make the base 0. So there are no asymptotes of the other kind. The other kind are the x equals. So is that horizontals or verticals? The x ones. Since there's no x asymptotes, there's no vertical asymptotes. All right. Okay, you guys are at the time to work. Please refer back to your notes. If you took good notes, you'd have all of these things like, what does bigger on top mean? What does bigger on bottom mean? What does bigger, same on both mean? That's why you took the notes on it, right? Okay. All right, that's all I have for you.